All right, so this video is going to cover section 2.2 in the geometry textbook, and 2.2 covers conditional statements. So let's go over what a conditional statement is. So a conditional statement is an if-then statement. Oops, I forgot to make this big. Speaking of if-then, there we go. So it's like, okay, if this, then this. So you're kind of relating two things, or saying if this is true, then this has to be true. So there's kind of, well, let me see if this will come up. So this is from your textbook. Yeah, and it's clear enough. Good. I will actually zoom in a little bit. Okay, so let's just go through their definition and how they write it. They say a conditional statement is a statement that can be written in the form if P then Q. So it's kind of the if then idea. This is the symbol for it. It's just a line. So this one is applying or leading you to this one. So it's like hypothesis. This is what you have. Oh, and here's your conclusion. So that's where the hypotenuse, the hypothesis, and the conclusion come from. Hypotenuse. Anyway, so this is kind of the idea that we're going to come up with and look at. So you have to write out hypotheses and conclusions. Is hypothesis a word? I don't think so. So let's look at like this first example that they talk about right here. If a butterfly has a curved black line on its hind wing, then it is a viceroy. So if this, then this. So our hypothesis is the if part. A butterfly has a curved back line on its hind wing. The conclusion is the butterfly is a viceroy. So let's look at the next one. A number is an integer if it is a natural number. It didn't go if then, it kind of went a little different. You have to think about it. If it is a natural number has to be your hypothesis. What you come up with is the number is an integer. That's your conclusion. So it doesn't necessarily written in the if then format. Typically it is, but not always. Okay, so let's look at writing a conditional statement here. Let me see if I can, yeah, it'll just show a little bit, so we'll just look at it that way. Okay, so if you want to write a conditional statement, that's an if-then statement from something. I'm only going to look at A. So a midpoint M of a segment bisects the segment. So that's what they say. Okay, the midpoint M of a segment bisects a segment. What is the hypothesis? What is the conclusion? And how can I write then the conditional statement? Well, you're saying the midpoint M of the segment then bisects the segment. So the hypothesis is like your first part. If M is the midpoint of the segment, then M bisects the segment is one way to write it. So you have to come up with the hypothesis and the conclusion and how to write it up to make sense as your conditional statement. Here's a little Venn diagram. You have spiders and you have tarantulas. The inner oval represents the hypothesis and the outer oval represents the conclusion. So what would be the statement? If an animal is a tarantula, then it is a spider. So if then coming from your hypothesis leading to your conclusion. So or your to your conclusion. I was thinking there was a different word. So that's one thing you might have to do. You might have to also analyze. So analyze is probably the one that people will struggle with the most. You have to decide if something is true, and you can come up with a counterexample that would make it not true, kind of like we learned in 2.1. So let's look at this first one. Determine if the conditional is true. If false, give a counterexample. Did you read that directions? That's common in your homework. You have to state true or false, but you also have to say if it's false, a counterexample. If it's true, you can just say true. So we wouldn't see this part. If today is Sunday, then tomorrow is Monday. Is that true? Well, yes, that's true. We don't have a counterexample, so it's true. Here's our next one. If an angle is obtuse, then it has the measure of 100. Are all obtuse angles have the measure of 100? Well, no. What if it's 105? You can draw any angle, or write it out in words. That would be a counterexample. So that one's false. If an odd number is divisible by 2, then 8 is a perfect square. So if an I find that one to be, I don't know if I read that one before, I'm looking at it. If you look at that one, what do you what do you think of? If it's odd number, is it even divisible by 2? Well, no. If it's odd, it's not even divisible by 2 evenly, right? It's going to give you a decimal. Then it is a perfect square. They have nothing to do with each other, so they're false. And you can give any, they just say an odd number is never divisible by 2, so the hypothesis is false. So the hypothesis is false before you even get to the conclusion. The number 8 is not a perfect square, so the conclusion is false. So kind of a weird statement, didn't work out all around. Okay, so that's kind of looking at conditional statements. So you might have to write a conditional statement. You might have to tell me hypothesis or conclusion. You might take some kind of sentence and make it an if-then, make it one. So let's look at the next couple definitions that they have. Okay. They have a little butterfly down here. So let's look at some different conditionals. Okay. If conditional is a statement that can be written in the form if P then Q, here's your symbol. Okay. The converse is a statement formed by exchanging the hypothesis and the conclusion. So if you exchange them, you would then be applying that Q leads to P. This is an arrow. It doesn't quite come through as an arrow on here for some reason, but that's an arrow. That's important on the symboling. But okay, so we have something called a converse. All a converse does is switch it. So you switch what you start with, your hypothesis and your conclusion, and you interchange those. So that is the converse. The inverse is a statement formed by negating the hypothesis and the conclusion. So negating, you change it so to be the negative of what you came up with. So the inverse would be switching both the hypothesis and the conclusion to be negative, like opposite. Oh, negating. So that is by this little squiggly symbol P, and that applies squiggly symbol Q. The contrapositive is the statement formed by both exchanging and negating the hypothesis and conclusion. So then you're applying that the negative of Q is now applying the negative of P. All right, so all of that is great, except now how would I see that in terms of a problem? Well, let's look at this kind of example they give down here in this. I like the way they kind of did this one. So here's our conditional statement. If the measure of angle A is 95, then A is obtuse. Is that true? If A is 95, is it obtuse? Well, yes, it is true. So our conditional is true. Let's write the converse of that without looking. What is the converse? Well, it's going to say if A is obtuse, then the measure of angle A is 95. Well, we already looked at one like that. If we say it's obtuse, then the measure is 95. That's not true. We can think of another obtuse angle like 100, 105, 200, not 200, it's too high, 100, anyway, no, 200 is okay. So that's false. So our converse is not true. But we could write our converse, right? You were able to write it. Now the inverse, okay. I have to look close at this. You take this and do the opposite. If the measure of angle A is not 95, then A is not obtuse. Well, can you think of of an A that is not 95 but is obtuse, that would be a counterexample. Well, sure, 92 is not 95 and it is obtuse. So the inverse is false. Let's look at the contrapositive. So that's switching these two. So if A is not obtuse, then the measure of A does not equal 95. So if A is not obtuse, so we're not obtuse, then the measure of angle A cannot equal 95. And this statement is true, but it's a little bit tricky. So if your angle of A is not obtuse, so we're not obtuse, we could be anything else, then the measure of angle A is not 95. There isn't an example. We're kind of applying a lot, though, with just saying it's not 95. But that is true, however. So that's kind of how we relate all of them. Let me think of one other thing. I thought I wanted to maybe look at my notes real quick. There was one. I think I'll actually pull up your homework and kind of walk you through that a little bit. So your homework is problems 13 through 21. So you didn't have to do a ton of these because I think they're a lot of writing. So identify the hypothesis and the conclusion of each conditional. So just to identify which one's the hypothesis, which one's the conclusion. Write a conditional statement. So you have to write a conditional statement. Okay, on this one, determine if the conditional is true. If false, give a counter example. And I didn't make you do, I should have made you do it, but I didn't. It doesn't have any other questions that relate the inverse that I made you do. I think I meant to go through 23, but that's all right. Write the converse, inverse, and so I should have gone through 23, but that's all right, too late. If you want to look at 22 or 23, that's great. That one just brings in all of what the idea of a contrapositive is. For this section, I just really want you to know how to write a conditional statement, know what a hypothesis is, know what a conclusion is, because switching it around and making it an inverse or a contrapositive, that's not a hard thing to do if you actually understand the if-then statement. So that's what I want you to get out of section 2.2 is writing an if-then or a conditional statement. And that concludes my little mini lecture.